So the first week of school, we learned all of these words. We learned conditional, converse, inverse, contrapositive, counterexample. We learned all of those words. Now each unit we're focusing on a different word. So last unit there were some problems on your test that had the word converse. Well, this unit you're going to be tested over some that have inverse. So the focus this unit is inverse, and then counterexample is going to stick around all year long. No getting rid of counterexample. So today I want to remind you what inverse means, and I want to go over some problems where we're determining the truth value of inverse statements, okay? So a reminder, an inverse of a conditional negates the hypothesis and the conclusion. If not P, then not Q. If you study for your test, then you will make an A. The inverse. If you do not study for your test, then you will not make an A. All right, let's try an example. Write the inverse down of this sentence, and then what's also really important is determine the truth value. If you think it's false, please write a counterexample. Well, this sounds familiar. If two angles form a linear pair, then they're supplementary. That's the linear pair theorem. That's the LPT. But we don't care about the original. That one's always true. We care about what the inverse is. So the inverse, if two angles do not form a linear pair, then they are not supplementary. So there's our inverse. If they do not form a linear pair, then they're not supplementary. Now it's time to determine the truth value. What do you think? Type it in the chat, true or false. Okay, so if you got false, you need to have a reason why. It can be a picture, a word, a phrase. You need to have a reason why. Would it be possible for two angles that are not a linear pair to be supplementary? Would it be possible? Of course, of course. So we can have angles that add up to 180 that are not adjacent to each other. So this one could be 20 degrees, and somewhere over here, this one could be 160. Those are not a linear pair, but are they supplementary? Yes, we just proved it wrong. So you would draw ones that are not adjacent, but that are still supplementary. All right, try this one. Write down the inverse in your notes. This one's a little bit trickier because it has the word not in it. So our inverse is if an angle is a right angle, then it is not acute. If it is a right angle, then it's not acute. We don't type not. The nots cancel, the double negative, and it becomes an is. Good. So true or false? My first period was trying to use obtuse angles as a counterexample, and I tried to explain to them that that would not be a counterexample, and they were getting confused. So remember, you want to look at your hypothesis. There is no changing the hypothesis. It is a right angle. So the angle that we're discussing is a right angle. Hands down, it's right. You can't argue that. Now what you can argue is whether this is true or false. So if we have an angle and it is a right angle, do you agree or disagree? It is not acute. Well, I agree. That angle is not acute. There's no right angle in the universe that is acute. So we're saying the conclusion is always true. It's always not acute. And so the truth value would be true. Good, good. Okay, let me give a little background to what we're going to be doing today. So in the past, from the beginning of school until now, you have done reasoning. You have. But it's been informal reasoning. You have explained your answer, and you've justified your answer a lot. We've used that word justify. Now, if you want to formally prove something, you haven't been proving yet. If you want to prove something, that would be a formal proof, and we can do that in the form of a flowchart, a paragraph, or a 2-column proof. We're going to learn this way, and this will be our go-to way, but I need to expose you to all the different ways. So in college, when I was a math major and I would go in to take a test, I would have to take the entire math class, like let's say it was calculus, and I was done taking calculus, but then I had to take a class where all I did was prove calculus. So every time I would show up to a test, and I would be writing paragraphs upon paragraphs upon paragraphs, proving different calculus theorems. I would show up with a stack of notebook paper. That's how I would take my test, not just solve problems and have numerical answers. Crazy. So we want to give you guys a taste of that. It will be very minor. So we're going to work up to this. We're not going to be doing 2-column proofs today. We're not going to do this today, but this is what we're working towards. So when you say, why are we doing this? When am I ever going to use this? We're easing you in to proofs, okay? So we're going to try a few examples and then we're done. So let's take a look at this example right here. So you start with the given information. You're always going to have something that's given. You're going to draw a conclusion, and then to back up your conclusion, to be like, well, this is why I'm right. To back up your conclusion, you're going to use a definition or theorem from that piece of paper that you got from the calendar. So here's the given. Angle DAY and angle YAK are a linear pair. So if someone gave you two angles and they said, hey, these are a linear pair, what could you conclude about those two angles? What would you conclude about their measures? Okay, very good. So we're going to conclude that angle DAY and angle YAK are, this is a long word, oh my goodness. We're going to conclude they are supplementary, and now we have to back it up with a definition or a theorem. What do you want to say? Why are they supplementary? Someone's like, why? Tell me why. I don't believe you. What do you say? Yes. And I do want you to write it out, but I'm going to abbreviate to speed this up. Why? Because of the linear pair theorem. Because my mom told me so. Because the linear pair theorem told me so. Okay, I want to try this one. So that was one where we used a theorem. I want to show you one where we're going to use a definition instead. Given angle NAT plus angle WED equals 90. Good. The conclusion is as simple as that. There's no theorem about angles that add up to 90, but there's a definition about that. So the conclusion is, hey, if you gave me these two angles, what could you conclude about them? Well, they add to equal 90. So these two angles, Nat and Wednesday, Nat and Wed, are complementary. And you would spell it out. What's the reason why? And now we're going to use a definition. Literally, you just put definition of complementary angles. That's all you write. Definition of complementary angles. You don't need to write the definition out. You just need to name the property or the theorem or the definition. I know I'm going fast. I know. Okay, let's try this one. Angle 1 and angle 2 are vertical angles. So this one, they gave us information, but they also gave us a picture. Sometimes part of your given is going to be a picture to reference. You didn't need that picture. But anyways, what's the conclusion? Good. The conclusion is that they're congruent. Okay? The conclusion is angle 1 is congruent to angle 2. The reason is the vertical angle theorem. Good. The reason is the that. So our conclusion is something about those angles, and then the reason is where we put the definition or the theorem. Okay, I'm going to skip that one and do this one. Last one. Given ray AB bisects angle cat. So this would be a time when I would draw a picture for reference. I would draw a picture. Uh-oh. Something happened to my smartboard. What do I always tell you to do when you see bisect? What do I tell you to immediately do to your picture? Oh no, my smartboard's not working anymore. Arcs, not hash marks. We're in the angle unit. Add angle markings. What do those angle markings mean? Well, they mean that those angles are congruent. So if you don't know, how to answer it, just think, what would I do to my picture? I don't know what happened to my smartboard. Oh no. Well, this is the last one, so I'll just have to say it out loud. So the conclusion is angle CAB is congruent to angle BAT. CAB is congruent to BAT. And what's the Y? It's another definition. Definition of angle bisector. Good.